So we are talking about image classification, then you're also telling that ML algorithm only works on numbers. Then how do we convert an image to numbers? That is the first step, right? So every image that you see can be divided into smaller portions, which you have heard of the term a lot of times, especially when you're buying a phone. So these small portions are called pixels. Okay, so what does pixel stand for? Pixel stands for picture elements. The smallest portion of an image is called as a pixel. Right? You'll probably say my phone is 12 megapixel, 60 megapixel, 24 megapixel, 32 megapixel, right? So what does it mean? When you say 1 megapixel, what is 1 mega? 1 mega is 10 power 6, right? So every image that you take has 10 power 6 pixels. Okay, so every image that you take has 10 power 6 pixels. Okay, now each pixel can be represented by a number. What is that number? That number is nothing but your RGB value. Okay, now if you see on the right hand side of my screen, you see a hexadecimal number that is being written, right? For every color that I touch, you see this hexadecimal value that is being seen with a hash code. This is nothing but the RGB values. The first 2 digits are for red, second 2 digits are for the blue, for the green, and the last 2 digits are for the blue. So every pixel that you touch will have a specific RGB value. Everyone knows what an RGB value is, right? So these range, the value of these numbers are from 0 to 255. Right? So now, if I just take a small example of a small image of just size 3 by 3, right? So this value could be 5, this value could be 150, this value could be 1, 0, 5, 4, and so on. Okay, now can you see that one image is now converted into a numerical format, can be converted into a numerical format. One image can be converted into a numerical format. So now we got what we wanted. We're able to convert an image, which we didn't know that can be converted into a numerical format, into a numerical format. So why did we convert it to a numerical format? Because our algorithm, our ML algorithm, will only understand numbers. So any data that you give me needs to be converted into numbers. So there are ways in which you can convert something called as categorical labeling, label encode, and all those things, which convert textual data also into numbers. Because without numbers, your ML algorithm cannot train. So the first step would be to convert any data that is given to you into numbers. Whether it is voice, whether it is text, whether it is image, whether it is song, sound, any data, any raw data that is given to you, you have to convert it into numbers. There is no other option. Okay, what we looked at right now is basically converting an image of size 3 by 3 into numbers. So we have converted each RGB value into a particular number, and we see that it's a matrix of 3 by 3, and each cell has a particular digit associated with it. Okay. Okay. 2 minutes for any questions. Anything that you didn't understand from what we have just heard, what you've just heard. Okay. Okay, fine, cool. So let me just repeat what is this RGB value. Okay. So RGB, R stands for red color. G stands for green. Blue stands for blue. Right. So these are the primary colors. If you want to get any other color, if you mix some proportions of all these 3 colors, you will get the other color. Right? You might have heard of this color, right? So RGB is called primary colors. Okay. So now every color has a particular number. Okay, so every color has a particular number. So when I say number, basically you can represent it in the number format. So why 255? So R value can be represented in 8 bits. So you need 8 bits to represent the R value. Okay, so 8 bits means the numbers you can represent with 8 bits is 255. Why is it 255? So if you take 1 bit, with 1 bit, how many numbers you can represent? You can represent 0 and 1. I'll just take a new. Okay, so with 1 bit, how many numbers you can represent? You can represent 0 and 1. How? So 0 is for 0 and 1 for 1. So if you have 2 bits, how many numbers can you represent? You can represent 4 numbers. That is 0, 1, 2, 3. So what are those in binary format? 0, 0, 0, 1, 1, 0, 1, 1. Right? So this corresponds, every time you have to convert it into binary, right? So if you have 2 bits, you can represent four numbers, right? So 0 to 3 is nothing but, can I say 0 to 2 power 2 minus 1, 0 to 2 power 2 minus 1, right? So 2 power 2 is 4, 4 minus 1 is 3. So 0 to 3 numbers you can represent with 2 bits, right? So if I have 3 bits, the numbers I can represent will be from 0 to 2 power 3 minus 1. That is 7. So 0 to 7 numbers I can represent. So what will be these numbers? So 0, 0, 0 will be your first number, that is 0. 0, 0, 1, that will be your second number. 0, 1, 0 will be your third number. 0, 1, 1 will be your fourth number. 1, 0, 0 will be your fifth number. 1, 0, 1 will be your 1, 0, 1 is 5. 1, 1, 0 is 6. And 1, 1, 1 is your 7. So 0 to 7 you can represent with 3 bits. So similarly, for representing the color red, you generally use 8 bits. So the values will be from 0 to 2 power 8 minus 1. That is 256 minus 1. That is 255. So for R color, for red color, if you have to represent, it will be from 0 to 255 minus 1. Okay. Similarly, for blue, you need another 0 to 255. For green, you need another 0 to 255. So any number that you pick from these combinations will result in one of these colors from that you can see here. So basically, we are converting the color representation into binary format. Okay, but we don't need binary format. We just need decimal numbers because our ML algorithm can understand decimal numbers. So we don't have to go until the binary numbers to feed them as input. Okay. Okay. So now coming back to image representation, we have understood that every image can be split into pixels, and now these pixels can be given as input. These pixels can be given as input. Okay. So how do we give this as input? So what we will do is, now this is a 2D matrix, right? So we will convert this into a one-dimensional matrix just to get the features. So each pixel is now can be called as a feature or attribute, right? So let's assume there are numbers starting from 0 to 9. So if you convert it into a one-dimensional array, the features will be 0, 1, 2, so on up till 9. Now these 9 are your features. So why are these called features? Because for every new image, these 9 values keeps changing, right? So let's say your image is somewhere like this. Okay. Now for the second image, let's say my number is 7. Second image number is 7. Okay. Now you see there's a difference between the pixel value. So here there is no entry, so that will be 0. Here there is no entry, it will be 0. Here there is no entry, it will be 0. So let's say it is 0, 0. Third, there is small entry here. Let's say the number is some 110. Then fourth, there is some number 110. Fifth, there is something called, let's say 150. Then sixth, there is some value. So for each of these 9 pixel values, some random values are, some values are here.
To watch the full Odin Talks video, click on the link in the description.